Okay. Hello, everyone. Welcome to another episode with your girl, Audrey. All right, so right now I'm trying so hard to get into my TikTok. I don't know why. Everything is all kinds of cuckoo Johnson, but I'm here. So tonight is going to be a continuation of what I was doing last night. So I am looking at those GED questions, those 4-point GED questions that we all need to kind of brush up on. Hey, Bri. So just to get those questions in, of course, tonight in the middle of a session, my electricity went out. That was crazy, and it wasn't windy or rainy. So let me get my mood lighting correct. But everything's all okie and dokie, and we're just going to get ready smoky. All right. So let's see if I can move this over or fixate it a little bit so you can see everything or mostly everything. All right. So this is what's happening. The table, okay, so the table below shows the number of students participating in various after-school activities. So if they're in sports, it's 120 students. Music, 80 students. Art, 60 students. And robotics, 40 students. So we are looking at what's called, what's called the data analysis problem. And when you think about it, you're going to be like, oh my goodness, this is so easy, right? So it's asking what percentage of the students participate in sports. So anytime they're doing any kind of percentage, it's always what you're looking for or the part over the whole thing. Okay? Usually percentages is like out of 100. But in this case, we're not really out of 100. One, we want to know how many total students do we have? So if I zoom in a little bit so you can see the chart, you got your 120, you have your 80, your 60, and your 40. So if you add all those up, how many total students do I have? Hey, misbehaving. It's been a minute. Thank you. Day was kind of crazy, but we are here. So how many students do we have total? 120, 80, 60, 40. Okay. Hey, Cash. Cash is saying 200. Rizzler is saying 300. Okay, there's a battle of 100. Which one's correct? Is it 200 or is it 300? Okay, Cash went back to 300. All right. Okay, Krista saying 300. Welcome in. Okay, Bri is saying 300. Okay. So 120 and 80, this is 200 right here. 60 and 40, that's another 100 right there. 200 and 100 will give us a total of 300. So now we want to know how many are participating in sports. So if I angle this a little bit more, if I'm noticing sports, I have 120 students. So now they want us to figure out our percentage. Okay? Thank you guys. Thank you. Thank you for participation. So now we're looking at 120 over 300. Okay? So we want to know what the percentage is. Now, we might want to take a look. So if we take care, they both end in zeros. And sometimes I always say, if you want to bring them down to more manageable, you can cancel out those zeros. So now you have 12 over 30. Now, If you want, you can actually divide 12 divided by 30, or you can simplify it, because I know 12 and 30 doesn't go quite evenly, but it's not going to be 20%. Yes, so bye, we can cancel those out. Hey, Amber, lovely to see you. Well, you're virtually, you know what I'm saying. Okay. So like 2.5, yes, you made it. Okay. So you can say 2 over 5, because say that they have 6 in common. If they have 6 in common, you got 2 over 5. But say I want to change that to a percent. So that means it's really going to be 2 divided by 5. So in order for me to have that 2 divided by 5, I need to put my decimal point and add a 0. So instead of a 2, because we know there's 0 groups of 5 that can go into 2, but there are 4 groups of 5 that can go into 20. And this gives us 0 as our remainder. There you go. So we got 0.4. All right. So 0.4, if I go with the percentage, that's actually going to be 40%. Okay. So 40% of that school's population, participants, do sports. Okay. All right. So you're always looking for the part over the whole. Okay, that's like the key thing. Remember, part over the whole. So here's another question. Let me unzoom quite a bit. Oops. So now we're looking at an area question. So they're saying the area of a rectangle is 72 squared units, and its length is twice its width. So find the dimensions of the rectangle. So we did a problem similar to this last night, but we didn't do area, we did perimeter. Okay, so if you're like, this sounds familiar, Audrey, it should. But this time we're finding area. So before we can do anything, what is the formula for area of a rectangle? Go ahead, put that in the chat. What's the area of a rectangle? The formula for area of a rectangle. Okay, B times the height? Yes. You can say base times the height, or you can say length times width. Okay, either one of them will work. So if we get our area, it's either my length times my width, or you can say your base times your height. Okay, so if there isn't a plus or a minus sign in between, it's understood that it's through multiplication. Okay, good. So now they're saying, so we got to kind of work a little bit backwards, because we don't have to find the area. They gave us the area. That's 72 squared units. That is the area. So that's going to be my A. So I'm going to write 72 right here. Then they told me that the length is twice the width. All right. So we're kind of looking at this first equation, but it's twice the width. Twice meaning multiplication, multiplying by 2. So my length, that's going to be 2 times my W, okay? Because the length is that. And the reason why I'm using W, because I'm just saying W is going to represent my width. Okay. Yeah, so it'll be 2W. Good. And our width will be our other W. So now, let's see, because we need to find the dimensions of the rectangle. So that means we need to find exactly what the length is and exactly what the width is. What should I do next? Or what could I do next? I know. So if this is multiplication, let's do the multiplication. Let me turn this down a little bit. So what should I do next? So I'm setting up my equation. So we have 72 equals 2W, which is my length, and W, which is my width. What do I do next? Okay, so combine the 2W and the W, multiply. Yes, we need to do that first before, Amber, we do yours. So 2W times W, this will give me 2W squared. Okay, when you multiply exponents, excuse me, when you multiply bases, you add the exponents. If you don't see anything in the exponent position, that means it's assumed to be a 1. So the bases are the same because they're W's. 1 plus 1 gives me 2. Then I bring down my 72. Okay, then I'm going to divide. Yes. So 72 divided by 2, that'll give me what, 36? W squared. Now, ACD, you're thinking the answer is going to be 6. What did you do in order to get 6? Okay, not a problem. So not square it. There we go, Bri. Okay, good. Yes, Miss Kitten, how are you? All right, yes. So in order for us to cancel out the square, we have to do the inverse. And the inverse of a square is a square root. Okay, so we're going to square root it. So the square root of 36, gotta remember to zoom in so y'all can see a little bit. So the square root of 36 actually gives me 2 answers. You're like, what? Yeah, because the square and the square root, they're going to cancel out over here. So that's how I got the W. Now the square root of 36, I can get 2 answers. I can get a positive 6, or I can get a negative 6. Anytime you're coming from an equation and they said my highest degree is to the second power, that means I'm going to have 2 solutions. But here's the thing. Does it make sense for me to have a negative 6? Does it make sense? In this situation, in this current situation, does it make sense to have a negative 6? You know, forget the math. Think about what we're doing. Okay, so Bri says no, it doesn't, because the number you're squaring is positive. True. But there's even something simpler than that. It's like, I don't think so. Because remember what we're looking for. No, because the area is positive. Okay. Okay, yes it does. Yes, negative times negative is a positive. True. But think about what we're trying to find. Yes. Hey, Pog. Okay, we're looking for dimensions of a rectangle. Can we have negative length of sides? Right? No. Okay. Oh, thank you. Okay. So that's the thing. We're looking for a dimension of a rectangle. So we can't have a negative length of a side. Okay? So that's why we're just going to go with just the 6 in whatever units. So my width is going to be 6 units. So we know what the width is, right? So it can't be, right? It has to something that exists. There you go, baby girl. Thank you. All right. So that's what our width is. Now, if you go back to the original expression, it says the length is twice the width. So for my length, remember that 2W that we had there? So instead of a W, we're going to take this 6 and we're going to substitute it in for that W. So that means the length, good, yep. So it would be 2 times the 6. So the length will be what? I try. Yes, Daryl, good. Typed too fast. There we go. Good, baby girl. There you go, Bri. There we go. All right. Yes. Okay. So it's going to be 12 units by 6 units. All right. So that's going to be the dimension of that rectangle. So the first thing you need to know was, what's the formula? What's the formula for area? Length times width or base times height. Either way, you're multiplying the one side and the other side. But when they give you the area, you're replacing this number for the A. Then you have to know what the word twice means. So twice is multiplication, so that's 2 times your width. And if you want to say your width was W, you can say your width is W. If you wanted to change the width to X, you could change the width to X. Okay, no matter what, it's going to be twice. Okay, once you plug it in, now we're going down into the solving. Remember, to get rid of a square is a square root. And once we get our answer, you're going to plug it into your length so you can find your length. Okay. You were worried. He's like, wait, what's going on? All right. So, believe it or not, that is a 4-point question. Okay. The statistics one that we just did earlier, that was a 4-point question. All right. So now this is definitely a 4-point question. So let me unzoom a little bit. Okay, anything dealing with that magical word called slope is definitely going to be a 4-point question on any kind of GED. All right, so slope means rate of change. For my IB or my international, slope is called gradient. Okay, so if you ever look and you're traveling and you're going up a mountain, okay, and you see like this little, I know, I'm going to draw. Here we go. Bring out the laughter. Okay. And they have like a hill and then there's like a percentage, right? And sometimes they even have like a little truck and yeah. Okay. All right. Okay. So there's usually something, and I'm actually going to zoom into it. That's funny. You'll see a sign on the side of the road and they'll give you a percentage and they'll give you some kind of code. And usually this is like when you're going up some kind of hill or a side of a mountain if you're traveling long distance. And this tells the truck drivers what to expect, what type of gradient, What is the percentage? And they know certain percents, they're like, hey, only certain loads can go through here. You might want to take an alternative route. Or it's like, okay, this is going to be the steep increase. Are you okay with that? So it kind of gives the truckers a little heads up about what they're going to see in the next few miles, right? That's what slope is. Slope is the rate of change. Right. So, slope, it just basically, remember, when you look at ordered pairs, you have two things going. You have your x values and you have your y values. So they want us to find the slope of the line passing through point 37. So this is my first point, so that'll be my x1 and my y1. The 1 is indicating this is the first point. The x always comes before the y. Think of the alphabet, x, y, z, right? The second point is 5, 11. So you have your x2 and your y2. Okay? So the reason why I have these subscripts of 2's there is because this is the second point. So for us to get our slope, which is represented by the letter M, okay, a lot of us know that, we use this formula. You can either say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can take it this way, especially international, because everyone, well, especially in most of the Asian cultures, they read from right to left. So it makes sense. But us in the States, and most other places, read from left to right. So you could say y sub 1 minus y sub 2 over x sub 1 minus x sub 2. The reason why, and I'm going to write the word or, right smack in the middle. The reason why I say this, because a lot of students generally get lost in the sauce when it comes to plugging this stuff into the formula. They do fine with the y2 and the y1, but then when it gets to the x's, they'll just put 3 minus 5. No. If you stick with the 2, if you go 2 to 1, that means you have to go 2 to 1 for the x's as well. Another phrase of saying this will be your M is basically equal to the change of y's over the change of x. So you got your deltas, okay? Right? Right. Everyone learned the first way. Everyone did. Okay? I'm going to show you both ways, and you decide which way fits or rocks your boat. So, for the first one, let me see if I'll put it in. I'll put it in black. So, for the first one, we have our y2, which is 11, minus my y1, which is 7, over my x sub 2, which is 5, minus my x sub 1, which is 3. So now, 11 minus 7 will give us what? I know, I'm insulting you, but just work with me. So 11 minus 7, okay? Bri saying it's 4. Okay, got something. Austin agrees with you. Great. All right, so we're on the right path. Then 5 minus 3. Okay, Amber took it to the next level. Good job. So we have 4 over 2. Yes. So that gives us 2. So now we have division. And we can simplify this. 4 divided by 2 that will give me a slope of 2. Now you can say a slope of 2 over 1, but remember, all whole numbers can turn into a fraction easily. All you have to do is just put it over 1, okay? And it won't devalue the original answer, okay? So now, let me show you if I do it the other way. So if I wanted to, I could say 7 minus 11 over 3 minus 5. Now, when you take the test, you don't have to do it twice. Remember, once you get your answer, keep it moving. But now we have 7 minus 11, so that gives me a negative 4. And then 3 minus 5, that gives me a negative 2. Negative divided by negative will give me a positive 2. All right? So no matter what, you're going to get the same answer for slope. Okay? This is how you do it. Okay? As long as, I like to say, as long as your y1 is over your x1, or your y sub 2 is over your x sub 2. Okay, you keep them with the same pattern. You don't want to have 1 minus 2 or y sub 1 minus y sub 2, and then it's x sub 2 minus x sub 1. Now, you'll get an answer, but it'll be mad wrong. All right? Okay, let's see. But doesn't it still make it improper? Well, remember, slope is a fraction. Okay? Slope is a fraction. Oh, hey, Lynette. Thank you. All right. So the first way you did it is the best way to do it. It doesn't matter. It doesn't matter. I know. It really doesn't matter because you're going to get the same answer regardless. Okay? So it's whatever you feel natural that you can remember that same pattern. Do that. When you said 2 over 1 as a fraction, doesn't that make it improper though? Yep. I think I answered that. I'm not sure. I'm just answering questions like a crazy woman. Yep, because even if you had a 2 over 1, that's fine. Because remember, this is going to be your rise, which is your y's, over your run. So your rise is going to go up or down. Your run is going to go either left or right. Okay? So slope is always going to be a fraction. Proper, improper, because you're using, when you're graphing, you're using your slope to find the next point. So you can draw your line. Okay. Okay. Yeah, you can say you like the first one. It's perfectly fine. Do what makes you... Oh, Lulu love. All right. Okay, so while I set up the next ones, because I think we have roughly, I can't remember how many I put in here, but I did like a nice amount, some with systems of inequalities. This was like from yesterday. And I know I could have easily put it on a separate sheet of paper, but you know, I want to keep it inside the book. So while I'm setting up the next one, because I didn't want to pre-tape all of them, because some of them might have a little less space than the other ones. But I definitely wanted to do this. So let's see. Oh, yes, definitely this one. So if you guys can continue tapping, that would be amazing while I set up the next one. And you can insert your questions while I'm setting these up. And if you know of anyone that's about to take the GED or the ACCUPLACER or even ASVAB, this will be good for a quick review, especially for the algebra component. Okay, like I said, for those that are taking the GED, trust me, guys, these are your 4-point questions. These are the type of questions that you want to be able to answer. Okay, if you can answer a good majority of these and all of the arithmetic, you will pass. Okay, you will pass. All right. Okay, so can we get it up to about, let's say about 4? If we can get to 4K, that will be awesome. And then I'll get started. I never thought I would be that person, like leaving it for ransom. Can I get 4,000 likes and then I'll show the next one? This cracks me up. Okay. Yeah, so this one we actually did this. I think it was sometime last week, if I'm not mistaken. Oh, perfect. Thank you, my dears. Or if any of you guys are small business people, go ahead and put your business in the chat too. Never know. Never know who's here. Okay, if you guys got a little small business, or I shouldn't even say a little small business. I hate when people do that to me. But if anyone has anything that you're selling, you have your craft. Keep it clean, keep it cultured. Sometimes I gotta say that because, I used to be a high school teacher. Trust me, kids will say the darndest things. So, all right. All right. Oh, don't hate graphs. Don't hate it. Okay, so, all right. Trigger is telling us a couple things. All right, let's see. So this is saying graph the function y equals -2 times x minus 3 squared plus 4. Okay, and they want us to identify the vertex, the axis of symmetry, the opening, as well as get some key points for the graph. So we've seen this before. This is what's called vertex form. Okay, so this is telling me my opening, okay, and also if it's going to be narrow or if it's going to be wide. My vertex is basically what's inside the parenthesis and this number that is our constant. Now, if I want to graph my vertex, anytime I see a parenthesis, I always choose the sign that's opposite what I see. So I see x minus 3. So that means the x value of the vertex is a positive 3. It's always opposite of what you see. Okay. So my y value is always going to be the constant, which is 4. Now, axis of symmetry, for those that weren't here last week, axis of symmetry, aka your AOS, is always going through your x value. Okay, it only goes through. It's a vertical line that goes through only the x-axis, depending. Now, it's also going to go through your vertex. So since the x of my vertex is 3, so is my axis of symmetry. Okay? So your vertex and your axis of symmetry kind of helps each other out a little bit. Okay? When it comes to the opening, I'm going straight to my A. And I'm looking at the sign of my A. So since my sign is negative, it's going to open downwards. Okay, so since this is negative, it's going to open downwards. So I can start plotting just a little bit. So starting at the origin, go to the right 1, 2, 3, up 1, 2, 3, 4, and be able to plot my first point. So that's my vertex. Now, I'm going to draw my axis of symmetry. So the axis of symmetry goes right through that vertex. Okay, so it's going to go right through it. Supposedly go right through it. I've been slightly off all day today. Okay, so this is your axis of symmetry. Now, we know it's going to open downwards. So this is one other thing that I want to add to this list. I want to use the y-intercept. So the y-intercept is when my x values are equal to 0. So if I go back to this lovely equation, I know a lot of people are like, oh, the answer is 4. If it was linear, yes. My y-intercept is the constant. But this is not linear. We're talking about quadratic. So this is a U-shape, or in this case, U-shape. So I need to go back to the original equation and substitute a 0 for the x. So if I do that, I'm going to put it like right over here. So that means I have my y equals -2 times 0 minus 3 squared plus 4. Okay. No, it doesn't go through the y. It only goes through the x's. All right. I know. So when I do this inside the parenthesis, 0 minus 3, that'll give me a -3. And we're going to square that -3. So -3 squared, that'll give me 9. So now I have to take a look. So we got -2 times 9. That gives me -18. Right? Plus 4. So -18 plus 4 gives me -16. And I do not have enough room for that. So I know that's going to be all the way down here because I didn't count by 2's. But there's got to be something else that I can use to help me graph this. Did I screw up? I'm getting -14s. Why am I getting -14s? Oh, no. Yeah, you're right. I did screw up. Still, I don't have enough room. I was like, did I screw up? Yeah. I've been off all day. Why not? Thank you. Okay. So either way, I do not have enough room on my paper. I know. I appreciate you saying that. I appreciate you saying that. But there's got to be another way for me to find out how I can graph the rest of this. Because we got our vertex, boom. We got our axis symmetry, boom. We know the direction is going to be downwards. And now we need to get some key points. What else could I do? Covers by Emanuela says plug a point, like say 4, 2. Oh. So if I plug 4 in this equation, you're saying I should get 2 out. Let's see. If I plug 4 in, that's 4 minus 3, that gives me 1. 1 squared is 1. Negative 2 times 1 is negative 2. And negative 2 plus 4 will give me 2. Oh. So we found 4, 2. What else could I do right now? Yep. So I could look at the x-intercepts. So if I do the x-intercepts, that means I need for this to equal, the y's to equal 0. I could find it that way. Yes. Okay. All right. So what is this for? This is one of those 4-point GED questions. So the highest points you can get on a question is 4. And these are one of those 4-point questions. Hence, you see how much work we're putting into it, right? So some people, Shane is telling me, okay, we got 4, 2. We also could have, there you go. There it is, Shane. You can also have 2, 2. The reason why the 4, 2 that we found is 1 unit away from that axis of symmetry. If I were to reflect to the other side of the axis of symmetry, I will get this point. And that's the one thing we know about quadratics. They are reflexive. Okay. All right. So if I did plug, let's say, a 1 in here, 1 minus 3, that'll give me negative 2. Negative 2 squared will give me a 4. 4 times negative 2 will give me a negative 8. And negative 8 plus 4 will give me a negative 4. So we could have 1, negative 4 as another point. Okay, so all you're doing is plugging in, trying a couple points, trying a couple. So now I am 1, 2 units away, okay, from the axis of symmetry. So that means I need to be 1, 2 units away from my axis of symmetry. All right, so now I got enough points. Oh yeah, we're good. Got enough points here. All right, so I can go ahead and try to graph my parabola. Okay. So we got the key is to find the vertex. Yep. And then you use the numbers beside it. Yes. Awesome. Okay. Perfect. So once you find that vertex, make sure you sketch that axis of symmetry so it'll be fine. A little bit easier to find the reflexive. All right. Nice. Good job, guys. Love this. All right. And you see how it just jumps from one thing to another. Because here is, now you see why I don't put tape on first. Because then I wouldn't have that much room. So from graphing quadratics, now we're going into probability. Okay, a bag contains 5 red marbles, 3 blue marbles, and 2 green marbles. What is the probability of drawing a red marble? Okay, let's get with that one first. So, there is always something in a bag. It's always marbles. It's always what probability is called with cards, with the dice, or the counting cube, as they want to call it nowadays, right? So, first of all, it still sticks with this whole process of part over the whole. So we need to know, what is my total? How many of these lovely marbles do I have in this bag? Like all together. Go ahead, put it in the chat. How many marbles is in this bag? Okay, so Tamika's saying 10, Cover's saying 10. Okay, says 10, good, 10, nice, lovely. All right, so we want to know not the probability of how many marbles total is in there, but the probability of drawing a red marble. What should my numerator be? Okay, Austin's saying 5. Okay, Lacole's saying 5. Okay, Sam's looking at my, telling me my 50%. Okay, Joe, good. Goth, Venus, yes. Okay, who else? Did I skip anyone else? Okay, so 5 out of 10. So the probability, if it can be reduced, just like, who was it? Sam that mentioned. 5 out of 10 is equivalent to 1/2. So this is your probability, and actually I should write it correctly, your probability of getting a red. Okay, so you'll see it written like this, the P and what you're looking for, your red. Okay, so the probability of getting a red is 1/2. Now let's go to the next one. What's the probability of drawing a blue or green marble? All right. Okay, based on the information that you know, what do you think? Okay. So Tamika's saying 3/10 and 2/10. Okay, so Austin again is saying 1/2. We're getting 7/10. Okay. Joe is saying 3 plus 2 over 10. Okay, so I do see that we're looking at the total, which is 10. Now, the probability of drawing a blue, and there are 3 blue marbles, or a green, there is 2 green marbles. So they both altogether have 5. Okay, so we're talking about 5 out of the 10 marbles that they have choices of. Yes. So if I reduce it, again, That will give me 1/2. Okay. Nice one. Good job. All right. It's awesome. It's awesome. It's awesome. Okay. So that's basically what you got to do. The main thing is to know how many total you have. Now, sometimes they will try to do like a combination. And I think I might do a little bit of probability a little bit later on. But they might say, what's the probability of getting a red marble, then a blue marble without replacement? Now, if you hear or see, well, probably not hear, if you see the words without replacement, that means, and I'm going to write this in pencil, that means if I originally had 10, out of the 10, we had, what was it, red marbles? Okay, we have 5 red marbles, right? Then, the next time, because we didn't replace that marble. Like we physically took a marble. I don't have one. Let's just pretend that this cute little clip is a marble, right? We went into the bag, snatched it. Oh, it is a blue marble. Yay, it's a red marble. Okay, we put it back. How many marbles is in the bag now? Okay. Hey, Zone of Friendship. I haven't seen you in a minute. I hope you're doing all right. Okay, good, Tamika. Yes. I don't know. Good, Paul. Okay, so now there's 9. If I said I want to know the probability of getting a red, then a red, then a green without replacement. Ooh, okay, handwriting's getting crazy now. So that means the first time we had a red, it was 5 out of 10. Okay. Second time we're going to get a red, it's not 5 marbles. It's 4. And then they say the next time is a green, right? So it's not going to be 9 marbles. It's going to be 8. But how many green marbles? Okay. Oh, do you? Oh, okay. All right. Yes. Good. So anytime they say without replacement, that means your denominator, or your total of marbles, is going to be decreasing, because each event has to be individualized, as they like to call it, independent event. So the first time you have 5 red marbles. The second time they want you to pick a red again. So that means you got to go 1 less. Then you got your green. Then you're doing, oh, how many green? Okay, they still had 2. But it was always 1 less. And what you do from here is you multiply. This is the fun part. So you got 20 times 2, that gives us 40. And then you have 72 times 10, that gives you 720. Okay. And if you want to reduce, I can look at it as 4 over 72. Okay. I like it when they both end in zeros. That means I can just cancel out the zeros to make my numbers so much smaller, right? So now you got 4 divided by 72, or reduced. And since there are, I was going to say 2, but I think it's actually 4. Divide by, yep. So if I divide this by 4, divide this by 4, I'm going to get 1/18. Yep, 1/18. So this will be the probability of getting a red-red-green combination without replacement. Okay. Thank you, Joe. Thank you, everyone. Good. Yep. All right. Yeah. It is a really low chance of this happening. All right, good. So yeah, so I just like to give you guys a combination. So again, a question like this, once you know what you're looking at, is definitely going to be a 4-point question. So anything with just simply adding fractions like 1/2 plus 2/5, yeah, that'll be like a 2-point question. Putting points on a number line, that would be a 1-point question. Plotting coordinates on a coordinate grid, that will be a 1-point question. Okay. All right. So, okay, so we have that one. Then, now remember, you don't have to get 100% on that GED. You want to try to shoot for that 168. Okay, do the best that you can with it and run with it. Okay, that's all you got to do. Because if you think, oh yeah, I got to get 100, you're going to stress yourself out. You're going to psych yourself out, and you're not going to want to do well. Okay, I want you to do well. All right, so we have, let's see, got a couple more. So, rectangular pen. Okay, we can do this one. Is the ACT or SAT easier? If you've taken up to Algebra 2, especially like around this time of year, I think a lot of people are taking the SATs and the ACTs, and that's always good because especially if Algebra 2 is somewhat fresh in your mind, it is a little bit easier. And I don't know what it is about the April test, but it seems like a lot more people pass in April than any of the months. I don't know if it's because you got more knowledge or the test itself is just easier. I have no idea. April just seems like to be a great testing month. Do you go live? Oh, when do I go live? Okay. I posted a new schedule, which I forgot to pin. There it is. I'm starting to go live at like 9:30 p.m. because I'm starting to get more clients during the day. So yeah, I had to make some changes. So Monday through Thursday, I will be on at 9:30. Thursday, I might be on at 1, depending on this one other client. But on Fridays, I definitely am 1 p.m. The weekends is like a wild card. Okay, that might be like a late afternoon. I'm not sure if it's going to be a late evening, but it also depends on how many more new clients I get. And I have like a couple more that's on the fence. Okay, yeah, because around this time of year, I get jam-packed, like ridiculous jam-packed. All right, so a farmer wants, let me unzoom so you can see. Just a little bit. A farmer wants to create a rectangular pen with an area of 300 square feet. The length of the pen is 10 feet longer than its width. So that sounds familiar. Okay, every time they keep giving these, trust me, they're in there. So first we need to write an equation to represent the situation, and then we need to solve for the length and the width. So let's do it. All right, so they're talking about area. Okay, so right away, I'm thinking of length times width. So they're giving us some information. They said that the area of the pen is 300. The length is 10 feet longer than its width. So 10 feet longer, so that means the width is being increased by 10. And our W is still going to be our width. Just going to make it into a W. Okay, so this is our equation. So it's 300 equals, now anytime it says longer than, that's addition. Okay, twice, that's multiplication. Thrice, that's actually a word. That's multiplication. You're multiplying by 3. Okay, more than, less than, more than is adding, less than is subtracting. Is more than, that's an inequality. Okay, and if you ever get stuck, hey, I got you. I got you. Okay, so this is like my handy dandy math notebook. And then I have some of the words and terminology that's being used. Okay, these are the most popular words that are being used for most word problems. So for addition, subtraction, multiplication, division, equals, and inequalities. So I used to see a lot of students when they say, when it's is more than, or they just say 5 more than X, they will put 5 greater than sign and then X. No. If it says is more than, it's an inequality. That's different from more than, as well as less than. Okay? So to kind of get an idea with that. All right? So, okay. Depends on the GED too. Yep. Depends on the GED exam. Yes, they do. Okay. So, taking a look, let me zoom in just a hair. So let's see, because now they want us to solve for the length and width. So right now, my equation is in terms of width, W. So since I'm multiplying, a lot of people will recall you're doing the distributive property. When you're doing the distributive property, you are multiplying. So that means I have W squared plus 10W. Okay? W times W gives me W squared. 10 times W gives me 10W. And I bring down the 300. Right? Anytime that I see a squared, that's telling me I'm going to have two solutions, that it is quadratic, and every time I have a quadratic equation, I need for it to set to equal to 0. So I'm going to subtract 300 on both sides. So I got 0 equals W squared plus 10W minus 300. Okay? Anytime you have an exponent, a high degree of 2, okay, that means I'm going to be doing some factoring. Okay, you see how this is going to be a 4-point question, right? Because now we're digging into some factoring. Since my leading coefficient is 1, okay, I can go right into my 2 parentheses. So I have a W here and a W here. So I split them into 2 different parentheses. So now I need to think, what 2 numbers multiplied together will give me a negative 300 and add together to give me 10? Okay. Okay. Not factorable? We shall see. Okay. So let's think of some products of 300. Excuse me. So friends like, I'm right. This problem is probably a typo. Probably. Okay. Okay. So we had 15 and 20. We have 10 and 30. Because obviously it's not going to be 2 and 150 because that's just too much. Yeah, I think you are right. Oh, is that 60 times 5? Yeah. Because even if I try to multiply any of these, or not sorry, well, one of them is going to be negative. But even if I make one of them negative, none of them combined is going to give me a 10. I think it's supposed to be a 20, like 20 feet longer. I think it's supposed to be 20 feet longer. Because it'll make sense if it was 20. Yeah, I think it's supposed to be a 20. And just like someone said earlier, everyone makes mistakes. So if that's the case, I think that's going to be a negative 10 and a positive 30. So that means I would do minus 10 and plus 30. Yeah, because I think the original typo was supposed to be, instead of 10, it's supposed to be 20. I think that's what it is. Because 10 times 30, yeah, that'll give me my 20. Okay. Right. Yeah. So I think that's what it's supposed to be. Because they wouldn't do, and I know like for GED, they're not going to give you any kind of like roots. Yeah, they're not going to do that. It's going to be actual sum numbers. Yeah, because they don't do too much with roots. Yeah, they're not going to do too much with roots. So what they're going to do is, I think it's supposed to be 20. So when we do the distributive property, you got your w squared plus 20w minus the 300. So what two numbers multiplied together will give me a negative 300. So we already got a couple of them here. One of them has to be negatives. Let me just make these negatives. To add together to give me 20. So it'll be our negative 10 and 30. So this will be a negative 10. This will be a positive 30. So now what we need to do is to set them equal to 0. So this one will be, my W will equal to 10 because we would add 10 on both sides. And this W will equal to negative 30. Now, remember, we're looking for dimensions of a rectangular pen. Can we have the negative 30? How many tutoring lessons do I do a day? Whew. Today I did 8. That was insane. To grab your orange daily heart. What does an orange daily heart do? You keep telling people to grab them. I think a couple people grabbed them. Like, what is it? What the heart does? We're going to have to talk. And you have to explain to me what the heart thinks. Okay? Yeah, quite a bit. Because I have not just high school students, I also have adults. So, and some of them are in the nursing profession. Some of them, they had a day off today. So, and then plus I have my Alaska kids. So I usually meet with them before they go to school, which is like the afternoon for me, which is all right. All right. So it can't be negative 30 because you can't have negative 30 feet or, feet. There's no such thing. But your width is going to be 10. All right. So now let's think this out. Sometimes you don't have to sit down and do formulas. Let's think this out. If the area is 300 and you know that your width is 10, what is your length? Okay, so the question is, a farmer wants to create a rectangular pen with an area of 300 square feet. The length of the pen is 20 feet longer than its width. So we needed to write, originally it said 10 and it just didn't work. So I changed it to 20 because they will not, put radicals in their answers. Very seldom with these type of questions. So then it's just like 20, and then you would do the distributive property. And then we were factoring. So now, if this is 300 and this is 10, that means my length is, Austin says, Joe says, side to side, to shy. Austin, checks in with TikTok. Oh, okay. Grab an orange heart. Is it gonna cost, is it a charge for people? I don't want to charge people just yet. If it isn't, that's fine. Yeah, maybe these tests are radical. Oh yeah. Sometimes. All right. Yep. 10 plus 20 gives us 30. Yes. Good. All right. Ah, tater tot. Thank you for sharing the love. All right. Okay. So we have a length of 30 feet and a width of 10 feet. Let's see. I think I have time for one more. And it is going to be a little intensive, which is good. All right. So what I have here is the system of inequalities. Now remember, you're not going to get 100%. Or maybe you do. Maybe you might get 100%. Don't let me just lower your shine. But what you're really getting is the equivalent of a C. And believe it or not, getting a C can open so many avenues for you. And then especially so if you see something and you're like, I don't think I know the answer to it, skip it, because remember, it's a time test. You can go back. Okay, just mark on like maybe your scrap paper, like which ones you skipped before you officially say, yeah, this is my answer. Okay. All right. So now, they want us to basically, solve the system of equation and then graph the solution region. All right. First off, both inequalities are set very similar to the equation line, which is y equals mx plus b. Okay, it'll give us our slope and it'll give us our y-intercept. So we can go ahead and see if we can set all this up. So I'm going to show you by graphing it what's happening. That's -3, that's +4. So this will work. Because the best part is we do not have to do a whole lot of rearranging. So you got your 1, 2, 3, 4, 5. I like to make my 5s a little more distinct. Easier to graph. All right. So when it comes to inequalities, I'm going to start with the first one. I'm going to do one that's red. Why not do Christmas colors? All right, so the first one I'm going to do that's going to be red. And the second equation I'm going to do that's a green. So I always start. Now this goes with any type of graphing. A lot of people just don't know where to start. If it's already in this equation, the line format, okay, the slope intercept form, you have a constant, there's a number next to your x, and y is by itself on one side of the equal sign. You always want to start with your b, your y-intercept. So for this first inequality, I'm going to start right here at -3 on the y-axis. So that's my starting point. From this point, I'm going to look at the slope. So the slope is a 2. Now we mentioned this before. Anytime I see a slope, slope is actually a fraction. So anytime it's a whole number, put it over 1. Because this is telling me from the point that we're starting at, which is a -3, I want to go up 2 and to the right 1. Up 2 to the right 1. And I can keep going as far as I want. Okay? Now, other thing that we know, just in case we can't go up, we could go the other way. Because remember, -2 over -1 gives me the same answer of a +2. Because a negative divided by a negative gives me a positive. So that means I could go down 2, but to the left 1. Down 2 to the left 1. Okay. I hope you do, Zone. I hope you do. Okay. Now, this is when everybody's like, oh, let me hurry up and graph it. Now, if this is a multiple choice question, are you listening to me? Take a look at your The second one is just less than, okay? If it's pointing to the left, it's less than. If it's pointing to the right, it's greater than. Now, if you take a look at the inequalities, I know when I see a line underneath the inequality, it's going to be a solid line because I'm including those points, okay? They're part of the inclusion. So it's going to be a solid line. If you look to see your answer choices and say they showed the graphs, and you see dashed lines for both equations, that's not your answer. We're looking for answers that's going to give me a solid line and a dashed line, okay? This one with the solid line has a positive slope, so that means from left to right, it's increasing, okay? Just like our red line. For the second inequality, we're going to start at 4 on the y-axis, and my slope is negative. So if I don't see a number, that means I got a -1 over 1. So that means from this point that we drew, I'm going to go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. And if you want to reverse it, you could say, from my starting point, I'm going to go up 1, but to the left 1. Up 1 to the left 1. Okay? Now, don't go crazy with like, oh, let me hurry up and draw the line. Stop. Take a look. It doesn't have a line underneath. So if it doesn't have a line underneath, you're doing dashed lines. So like draw, pick up the pen or the pencil. Okay, so they're going to be dashed lines. Don't have to get that crazy. So now, our things are intersecting. And you're probably saying, hey, Audrey, you're missing something. I'm like, yes, I am. Because I was looking for my colored pencils and they are not at my reach. So this is what I'm going to have to do. With inequalities, we have something called shading. So instead of me sitting here and picking out each and every single solitary point, I can shade so we can get that regions. So basically all the points in that particular region is going to make both the top inequality and the bottom inequality a true statement. That's what we're doing. We're looking for true statements. Okay, good. Okay, looking for true statements. So the red line, it's dealing with numbers that are greater than or equal to. So greater than means I'm shading above this red line. If I am not sure if I am shading this red line, I'll use the point 0, 0. Okay, most of the time, most of the lines are either on one side or the other side of this origin. So if I plug the 0 in for y and for x, I'm going to get y is greater than or equal to -3. Because 2 times 0 gives me 0. 0 minus 3 gives me a -3. So, is this a true statement? Is 0 greater than or equal to -3? Okay, think about the number line. Okay, all right. So 0 is bigger than -3. Okay, think of that number line. So let me put it over here. Okay, so if I have the number line, say that this is 0, this is -1, this is -2, -3, this is 1, this is 2, this is 3. Okay, 0 and going into the positive direction, 0 is bigger than -3. Okay, so 0 is bigger. So that is a true statement. So you're going to shade the side that gave us that true statement. So now, same thing we're going to do for this green line. They say less than. So less than, you're usually shading below. Okay, so we're usually shading below. And if we're not sure, let's use 0, 0. So I got 0 is less than 4. Is that a true statement? Yes, it is. So we're shading the side that contained that point 0, 0. So then it asks, where is my solutions? So basically you're looking at where your points or your shading is overlapping. And they're overlapping right in this section right here. And I like to just go over with a darker pen or pencil. Normally when I do these, I like to do it with highlighters. So I would get like a blue highlighter and a yellow highlighter because yellow and blue makes green. So when they do the shading, all of a sudden this thing illuminates into a nice pretty green color, even though one side is yellow and one side is blue. Okay. Yes. Okay. Hey, Mr. Math. Right? So we're looking at when they're overlapping. So that's why I always say they give you little clues, especially if you're taking your GED test. Can't even speak anymore. All right. So if there is a line underneath, it's a solid line. If there isn't a line underneath, it's a dashed line. Greater than, they usually shade above. Less than, you shade below. But you always want to just test it, just in case you I don't know which one's top, which one's bottom. Then test it with 0, 0. Okay? Plug it into your inequality and see what you get out of it. All right? Questions? All right? Would you like more of these? Because I know I definitely want to touch on exponents. I don't know why. It just seems like a lot of people are starting to get a little confused with exponents. And I know I definitely want to add exponential growth and exponential decay. Okay, I definitely want to do that as well. All right. Okay, yeah, not a problem, Lexi. Not a problem. All right. Okay, if there isn't any questions. All right, so I think for next time, I think it's either I'm doing arithmetic and geometric sequence, or I'm finishing up on exponential. I couldn't remember which one I wanted to do. I think I wanted to go with exponential growth and decay, because I do recall seeing, somebody said they were seeing that in their classes. Could you do some on finding the volume of cylinders and things like that in the future? Actually, I did do that. If you go to my YouTube channel, it should be up there. If it isn't, I'm going to take a look. So, Audrey Codner, GED Math Tutoring. Okay, go to my YouTube channel and take a look, because sometimes I put my lives, all of my lives go on that channel. And I do have a couple more that I was going to upload today. Yeah, so what I did yesterday will be going up sometime tonight. I don't know why. If it's my computer, I don't know. It just takes everything forever in a day to upload. Okay. Now, if you like the construction of my books, okay, this is one of my notebooks. I created this math notebook, okay? So I wanted to get some more organization going on in for my students. You know, you can take bits and pieces of your worksheets to put in there, or here goes that vertex form, or you can basically create your own notes. And what I like about it is that you have your formulas on one side, you have your steps on the other, and then you have your examples. So either you can use with the dots, or you can also use with the grid. Now, besides 100 pages of these, if you struggle, remember we were looking at factoring, I do have the factor sheet from 1 all the way up to 200. So looking at your factors, if you're trying to break down radicals, if you're trying to just find the right factors that's going to help you with that centerpiece, definitely take a look at that. Then we talked about the rules of integers. That's going to be here. We talked about the words, the different terminology that represents different operations. Then we were kind of talking a little bit about that slope-intercept form. We discussed that. We also discussed slope, so that's in there as a reminder. And then also your quadratic equations, that vertex form. And then the properties of exponents, order of operations, US and also international. So it just kind of gives you those reminders. Here's something for geometry. And then you have your volume and your surface areas, because that's going to be on there as well as Pythagorean theorems, SOHCAHTOA, the identities. Like this book is designed to handle Algebra 1, Algebra 2, and some pre-calculus, okay? Just to help people get organized and just have some of the most used sections put in there, as well as giving you a small brain break, okay? So all of this, and I'm selling it on Amazon. I'm working on another place just in case. And I am in the process of copying all of my notes, and I'm actually going to put them on sale, because a lot of people tend to like my notes. I don't know if it was the colors or it can't be the handwriting. It just cannot be the handwriting. But it kind of gives you an idea. Some people actually like to have the notes so they can kind of look over it. If anything, I also have one for 4th through 6th grade. And it has a lot of the resources as well, a lot more with decimals and fractions, dividing the conversion chart. Some of this very similar things that the other one has, except for this has an example of an equation that is actually solved, as well as the factor sheet. But theirs is a little bit larger, because I want them to practice like getting their 1s, their 10s, their 100s, so they can get a lot of the practice using the math tiles. Okay? Yep, and this is for 4th through 6th grade. All right? So that is it. That is it. So if you enjoyed this, I'm so glad that you guys came. I'm hoping that you guys are also learning a little bit. If anything, if you haven't done so already, if you can look me up on Google and just do a Google review for me, I would greatly appreciate that. I really want to hit my goal of 100 before the start of the next school year. And plus, the more activity that I get on my Google business, the more it pushes me past all those big name tutoring companies. And also, subscribe to my YouTube channel. Go ahead. Don't be afraid. I'm not going to harass you. It's actually going to be stuff that you're going to see. A lot of my old lives, some of the shorts that kind of helps you a little bit. And then I do have a new schedule for my lives. As I said, Monday through Thursdays is going to be 9 p.m. Eastern Standard Time. Fridays at 1 p.m. I think this Thursday I'll be able to go twice. I'm going to try to go for at 1 p.m. as all, in addition to the 9:30. And on Saturdays and Sundays, it's a wild card. So it could be at 10 p.m. It could be at 8:30. It all depends on how soon I get complete my tutoring sessions. So that's the only reason why I would do it kind of late. All right. So that's all. Thank you so much for everything. Oh yeah, 6.3. This works. Not bad for a Tuesday night. All right. So if anything, we're going to continue on doing great stuff. Keep being awesome, guys. I am definitely going to wrap this up, and I got to check all my messages and everything and get myself situated for tomorrow. You know, always helping as many students as I can possible. All right. Not a problem. Not a problem. Always willing to help out. And if you do need me, don't wait until, the next one. You can DM me. I will respond to you. Especially if I recognize the name, I will definitely respond to you. Okay. If you want private tutoring, I do have a few slots left. And when I say a few, I mean, I'm really stretching it with 4. But yeah, it's a good solid 2. But if you do need that, just let me know. Or if you just want like, hey, Audrey, can you take a look at this? Sure, I'll take a look at it. Just keep it clean. All right? Because we're not doing that. All right. So if anything, have a wonderful night. Keep being awesome. And keep motivating people. We need you. Okay? We need your motivation. We need your inspiration. So no matter what, just keep being you. All right. Love you guys. Have a good night. Take care.